Hello everyone and welcome. Today we are going to introduce something we call motion graphs. Now quickly, as a quick reminder, a graph is a representation on the x and the y axis used to show the relationship between two variables. So you must have two variables in order to get a graph. The types of graphs we are going to talk about. First of all, we're going to talk about displacement versus time graphs. So our two variables are displacement and time. And the other form we'll see right now, it's going to be about velocity and time. So our constant variable is going to be time. Once we're going to talk about displacement and time. Once we're going to talk about velocity and time. So let's start with displacement versus time graphs. So they are simply graphs that show the relationship between displacement and time. That's obvious. Now this is the x-axis and this is the y-axis. Normally the x-axis goes for the time and the y-axis is for the displacement, as you can see in this graph. Okay? Now we're going to talk about three types of displacement versus time graphs. The first type is called the constant graph. The second is the linear graph. And finally the non-linear or curved graph. And we must have dealt with those types of graphs and other materials such as math, for example. Now let's start with the first and the most simple type, the displacement versus time graph when it is a constant graph, okay? Let's study this graph and see what it means. Now, let's give certain values. For example, time here is in seconds, 1 second, 2 seconds, 3 seconds, 4 seconds, etc. And for displacement, let's say that the value here was equal to 5 meters, for example, okay? Now, from this graph, we can understand that it is saying that although time is passing, time C it's passing 1, 2, 3, 4, etc., but the displacement is still the same. The displacement is not changing. So this simply means, or this graph simply means, that there is no movement. The object is not moving. So a constant graph in a displacement versus time graph means that the object is not moving. Let's look at the second type of graph, or the linear graph, okay? Now, let's try to study the relationship between displacement and time in this graph. Let's give certain values, for example, 1, 2, 3, 4, etc. And here we have values 1, 2, 3, 4, etc. Now, what this graph is saying, first of all, we can say that the object is changing its displacement at a constant rate. See, for example, at 1 it was 1, at 2 it was 2, at 3 it was 3. This means that the object is changing its displacement at a constant rate, which means, in other words, that there is a velocity because the displacement is changing, but this velocity is constant. We have a constant velocity, okay? Now, what we can also conclude from this drawing, since the speed is constant, this means that the acceleration here is equal to 0. The second and most important thing that we can take, or we can conclude from this drawing, is that the slope of this line will represent the velocity, okay? As a quick reminder, what is the slope and how can we calculate the slope? So let's find the slope using these three simple steps. So the slope of any linear graph, and the graph must be linear, can be found using these steps. Step number 1, we are going to take any 2 points on the graph. It doesn't matter. Any 2 points on the graph will do. So this is our displacement versus time graph, and we're going to take 2 points. Step number 2, find the x and the y coordinates of these points, and let's call them x1, y1, and x2 and y2. So let's see on the graph, x1 and y1, it's the closer point to the 0, 0, or to the point of origin. So it's closer, the closer point will take x1 and y1, and the further point will take x2 and y2. The next step is going to be as following. From these points, or these coordinates that we got, we can find the slope using this simple equation. The equation says that the slope is equal to y2 minus y1 divided by x2 minus x1. So it's the change in the y components divided by the change in the x components. Using this equation, we can find the velocity. Now, let's prove that the slope is equal to the velocity. How are we going to do that? Well, remember that the x-axis represents the time, okay? and the y-axis represents the displacement, okay? Now, from the previous equation, if we replace x with time and y with displacement, we will get the velocity equation. Let's look at it here. So slope is equal to the change in the y-axis. The change in the y-axis means delta d. And x2 minus x is the time axis, so it's delta d over t. So simply delta d over t, we know that it is equal to the velocity, okay? So in other words, the slope, or we just proved that the slope is similar to the velocity. Okay. Now if we want to look a little bit more deeply in the displacement versus time graphs, let's look at this drawing right here and what it indicates, okay? Where we have three graphs, let's call them A, B, and C. If I told you to describe the motion of each of these objects, we can say that A is moving at a high speed because it has a high slope. Because the slope here is steep, we can say that it is moving at a high speed. Well, if we want to compare it with B, B is moving at a lower speed because it has a lower slope. And finally, how can we describe C? Think of it for 1 second. Exactly, we can say that C is going backwards. This means that the object is going backwards because it has a negative slope, okay? So this was just as a quick example on how we can describe the motion of objects on a displacement versus time graph. Now, let's look at the third type of graphs, which is the non-linear graph, okay? In other words, it is the curved graph. Now, from this graph, the displacement of the object or the car is varying with time. That means that the displacement is changing. The amount of displacement moved in a certain amount of time, it's changing each time. This means that the velocity is not constant. The velocity is changing. Well, and since the velocity is changing, this means that the acceleration here is not zero, because change in velocity means that there's acceleration. If we have constant velocity, that means we have zero acceleration, okay? Now, if we want to take a deeper look on curved graphs and describe the motion of these two objects, A and B. For object A, we can say that it is accelerating because the slope is increasing. The slope of the object, if we want to look at the slope at each moment, for example, at this point, the slope is approximately like this. At this point right here, the slope is changing. It's becoming steeper. That means that it is accelerating. The speed is becoming faster. Let's call this, for example, V1 and this V2. We can clearly say that V2 is larger than V1. And since the speed is increasing, the object is accelerating. And it makes it clear that object B is decelerating, and it's becoming slower. The object is becoming slower. So we took a quick look on displacement versus time graphs. There are three types. We said that there's the constant graph, there's the linear graph, and we have the curved graph. And now we understand what each of them means, or what motion can we describe from these three graphs. Watch the next video where we will be introducing velocity versus time graphs. See you then.